Hello everyone, welcome to AGENTIC RAG from Scratch series. In this series, we'll build a production grade AGENTIC RAG system step by step. This is episode 2. In this video, we'll make our first call to LLM, then integrate it with our React frontend. Then we will dive into streaming, enable our backend and frontend to support streaming. Once again, welcome to Building SaaS channel and let's get started. Let's start by installing LangChain. LangChain is an open source framework that provides pre-built agent architectures and integrations with many models and tools. This allows you to build AI agents that can evolve quickly as an AI ecosystem changes. Next, we need to install AI provider that we want to connect to. Since we'll be using Claude, we'll install LangChain's Anthropic provider. If you are using any other models like OpenAI or Gemini, you would install provider for that model instead. Now, let's create an API route that our frontend will call. Inside the endpoints folder, create a file called chat.py. First, initialize the API router from the FastAPI. Next, define a message model that extends Pydantic base model. This model represents the request format that our UI will send to the server. After that, create a response model. This will define the response structure that our backend returns to the client. Now let's create a post endpoint with a route/chat. Inside the endpoint, we will call chatService.invoke method, which we will implement next. Once we receive the response from the service, we format it using our response model and send it back to frontend. Now, let's implement chat service. First, import chat Anthropic from LangChain's Anthropic provider. Then initialize the model by specifying which Claude model you want to interact with. After that, call the model's invoke method and pass the message that the user sent. Finally, return the response from the model. For this to work, we need to configure Anthropic's API key. Add the environment variable Anthropic API key. You can generate your API key from platform.claude.com. Now we need to register our API routes. Include the chat router in the main router file and prefix it with v1. This gives us clean API structure for versioning. Now let's start the FastAPI server. Once the server is running, navigate to FastAPI docs page that gets automatically generated. From here, we can test our /chat endpoint, enter a message and execute the request. And there we go. We have successfully sent a request to Claude, processed the response through our backend, and returned the answer to the client. This is our first working integration with an LLM. Now, let's integrate our API with React frontend. We already have a base React application set up. If we run the application now, you will notice that the base layout is already in the place. The first thing we need to do is add an input field where user can type their questions. Next, we'll add a message section to UI. For now, we'll render some sample text and later we'll dynamically display a message received from our backend. After setting up the UI, let's implement the send message functionality. We'll create a function that gets triggered when user clicks on send button or presses enter. Inside this function, we'll make a fetch request to our backend API, passing the user message as a request payload. Once we receive the response from the server, we'll update the message's state and render the response in chat interface. Now let's run the front-end application, enter a message and see the response coming back from our AI backend. And just like that, we now have a working end-to-end AI chat flow between our React UI backend LLM service. Now as you see, waiting for the entire response to be generated before sending it back to UI takes quite a bit of time. To provide a better user experience, we are going to implement streaming. Streaming is a process of sending data in small chunks as it is generated, instead of waiting for the full response to finish. This allows the UI to start displaying the response immediately. Most modern LLMs support streaming. So let's go ahead and implement it in our application. Let's start with backend. Instead of calling model.invoke, we'll now call model.aStream. This method returns the response as a stream of chunks rather than a single completed response. We then loop over these chunks. LangChain supports chunk aggregation, meaning we can simply add the chunks together to reconstruct the full response. We will make use of this later in upcoming episodes. For now, inside the loop, we yield each chunk back to frontend. We format the output with ID, event and data, which follows the server sent event specification. Next, inside our router, we change the response type to streaming response from FastAPI. We pass our chunk generator function to the response and set the media type to text/event stream. This tells the client that the response will arrive in continuous stream of events. Now, let's move to front end. On the front end, we need to read and process the incoming stream. The first step is to pipe the response through multiple parsers that we have created to transform the raw stream into a format we need. The first parser is text parser. This parser decodes the raw chunks of stream and forwards the decoded text to SSE parser. Inside the SSE parser, we take the parsed text and split it by new lines. Then we construct an object that contains ID, event, and data. Next, the data moves to JSON parser, where the data field is parsed into JSON object and passed to next stage. Finally, we get the stream reader, loop through the chunks, and continuously update our message state in React. This allows the UI to render the response as it's being generated. And that's all we need to enable streaming in our UI. We have also added React Markdown so that UI can properly render the Markdown format response that most LLMs generate. Now let's start the backend server, run the front-end application, and execute a query. As you can see, the response is now streaming live to UI instead of waiting for the entire message to be completed. This makes our application much faster and more interactive for user. That's it for episode 2. In the next episode, we'll add conversation ability to our application and work on memory management. If you have enjoyed this video, don't forget to like and subscribe to Building SaaS channel. Thanks for watching. I'll see you in the next one.